Welcome back, guys. We're closing in on the end, and now it's time to talk about the curious case of restarting. And this is something that has to do with taking advantage of what you might have learned. Now, what is this about? Well, it's based on two observations, really. Is that if you make mistakes early on in the tree at very shallow depth, those are very costly. Because you're going to have to do a lot of work before you can backtrack over those decisions and reconsider them. So it takes a long time to revisit decisions that were shallow in the tree. And if your variable selection uses some form of learning, if it has a learning component, as you work down the tree, it's going to learn lots of things, but we're not going to put all that learning to good use for making those early decisions because we've already made them. It's too late. The behaviors that you're picking up, you don't have them at your disposal at the early stages. So how do we deal with that? Well, the corollary is a simple idea. It's give yourself a chance. If it doesn't work, start all over again. It's Groundhog Day. You have a wiser heuristic, you might as well start from the root of the tree with the information you have picked up during the previous iteration and redo the search with that new information. Now, armed with that better guidance, you will make better decisions closer to the root and hopefully head for a high quality or a feasible solution much more quickly. Now, of course, the question is, when do you decide to give up? Well, the way to do that is with a limit. You can limit something, and you could limit the amount of time or the number of nodes or the number of failures you've experienced during the search. And there's many ways to do that. One of them, described in this paper, is a Louv limit. It's basically repeating a pattern that you see, like the pattern in black, 1, 1, 2, and then you do 1, 1, 2, 4. You take the last one, you double it, then you repeat 1, 1, 2, 1, 1, 2, 4, 1, 1, 2, 4, and then you take the last one and you double 8. The black, red, and green run are basically giving you different limits. And all the time you're using short limits and then progressively increasing, making yourself more likely to go deeper in the tree and look at alternatives, right? And remember, these are limits on the number of failures. There are other options as well for doing that, but this can be quite effective. It's just restart the search. It doesn't work, do it all over again, but use the knowledge you have gathered from previous runs to do better this next time. So it's a simple trick, it works wonder. What's nice is that you don't even have to have learning, you just have to have randomization. If there is randomization in your variable selection heuristic, this works equally well. And it even has a name. This is called the heavy-tail phenomenon. It's all about the fact that if you look at the distribution of runtimes of search procedures for a specific instance, assuming you have some form of randomization, the distribution has infinite moments. That is, the mean and the standard deviation are infinite. The tails of the distribution are quite thick. And you can have some runs that are extremely long, and some of them finish quickly. So the implication is some of the runs are very long, and some of the runs are very short. Run for a while, and if you're not getting anywhere, restart. If you have randomization, you might hit a better run this time that's going to be short, right? That's the basic idea behind that. That's the illustration that gives you this kind of a picture. So this is a handful, if I remember, something like 20 or so instances. And you see the number of backtrack for these instances depending on the restart that you're doing. And you realize that the number of backtracks can be as low as just a handful and as high as hundreds of thousands. So try for a while, it doesn't work, restart, redo it again. Randomization will help you hit a short run at some point. Brilliant idea, works really well. Restarts are one of the very effective techniques to combat phenomena like heavy tails that we have discussed, or poor heuristics, where you want to have the learning have an opportunity to pick up facts and then use them in a subsequent run. So that's it. That's everything I wanted to cover. So to wrap up what we've learned this week, I'd like to remind you that variable selection using a first fail heuristic are extremely important. We have the min-dom and degree-based heuristic. We have impact-based, activity-based, last conflict, conflict order search, and this is just a sample. There are others like counting search that can come in handy as well. We have also value selection heuristic, and we can use bound impact value selection for actually probing and doing a limited look ahead to see which values are good, particularly useful in constraint optimization problem. And if all else fails and your heuristic is not as good as you'd like, you can still use meta-heuristics like restarts or discrepancy-based search or even LNS, which probably will be covered in another module. With this, that's a wrap. I hope you enjoy this and see you soon. Bye-bye.